Hello everyone, welcome to Caltex Academy. Today we are looking at derivation of product rule. Most videos use product rule only, but they can't show their audience how it is derived. And in this video, we have just tuned to a right one where I'm going to walk you step by step on how to derive product rule before looking at an example. So please keep tuned to the next video where I'm going to discuss some example using product rule. So without wasting time, let's dive right into the video. And when you are given a function y equals to uv, where u and v are in terms of x, so we can call this equation number 1. And then we'll have y, u, v increase with small increments depending on their variables. So here y is going to increase with a small variable delta y equals u will also increase with delta u, then we multiply it by v with small increment of delta v. And also let's go ahead and call this one here equation 2 minus equation 1. Therefore, from the left hand side, we'll have y plus delta y minus y from equation 2 and equation 1. So in the right hand side of equation 2, we have u plus delta u times v plus delta v minus, in equation 1 we have u v. So we notice that from the left hand side of this equation, y positive will cancel with this y negative, and the only quantity left here is delta y. And from the right hand side, we can expand this by multiplying through. So u times v, we get u v. Then u times delta v, we get u delta v. We go to the next quantity here, delta u. Delta u times v, we can write this in terms of v delta u. Then delta u times delta v, we will get delta u and then delta v, then minus our u v. So having done this, we also see that our right hand side, they have something in common that can be cancelled, and that is uv positive and uv negative. So after cancelling it, we can rewrite the remaining terms. So we have here delta y equals to u delta v plus v delta u plus delta u delta v. So delta y by delta x equals u delta v divided by delta x plus v delta u divided by delta x, and then plus, let me make this in terms of a term that will multiply delta v divided by delta x. So having reached to this stage, the next thing from the definition is, as delta x tends to 0, what happened to this side? So our delta y by delta x will turn to dy by dx. Also, delta v by delta x will vanish to dv, then dx. At the same time, delta v by delta x will tend to dv by dx. Now we also notice that as delta x tends to 0, if the vanishes to 0, what happens is this quantity here will approach to 0. So both delta u and delta v will approach to 0. Now if that is the case, we are replacing this by 0. Now we can write the whole expression in terms of dy by dx equals to u dv by dx plus v du by dx, and then remember our du or delta u has turned into 0, and then we are multiplying it by dv by dx, and because of this 0 multiplying this quantity, everything here vanishes to 0. So therefore our result of the derivation is dy by dx equals u dv by dx plus v du by dx, and this is what is known as product rule. Now somebody can put it in a different way, or starting with this term, because you can imagine this way: if you have 2 plus 3, the result is 5. Then somebody can write 3 plus 2, you still get what? 5. So with all this, if you go ahead and write this formula in terms of dy by dx equals to v du by dx plus u dv by dx is 100% valid. So these are two options in which we can write product rule. So thank you very much for watching up to this time. Please support this channel by liking this video, subscribe to the channel to get notification for more interesting videos, and please keep tuned to part 2 of this, where I'm going to show you some example on how to use product rule. With all this said, thank you, see you in the next video, bye.